In present value annuities, a series of payments are made over a specified time period to pay back an amount borrowed from a financial institution, for example, a loan from a bank. And the remaining balance on the loan is charged compound interest. The idea is you take a certain amount as a loan now, then you need to pay it back in regular installments, and with each installment you pay, the amount you still owe is charged interest, and that interest is added to how much you owe. Here's an example which I'll use to demonstrate how the present value annuity equation is derived, similarly to how I did with the future value annuity equation. You take a loan of 5,000 Rand and want to pay it back in 4 equal installments at the end of each of the next 4 years. At any given time, the remaining amount of your loan, which you haven't paid, gains interest at a rate of 10% per annum. What fixed amount would you need to pay for each yearly installment? I'll start by drawing a timeline. I think the diagram is a good enough picture of what's happening. The numbers at the bottom represent the loan. So you take the loan of 5,000 Rand now at T0, so the loan increases by 5,000, which is why it's written as plus 5,000. Then as time passes, it accumulates interest and increases in value, but at the end of each of the following 4 years, you remove a certain fixed amount X, which is deducted from the 5,000 and its accumulated interest, which is why it's written as minus X. And the overall goal is that by the end of the 4 years, you want the loan value to equal 0. So the question is, what is the value of X? Let's first just write what we know. They told us the interest rate is 10% per annum, so it would be 0,1. Let's say that the 5,000 you owe can be split into 4 amounts, F1, F2, F3, and F4. Don't worry yet what they are or what they represent. Just think of them as 4 numbers that add up to give 5,000. If we wanted to calculate how much interest the 5,000 accumulates with time, the 5,000 is the principal amount. We know the 5,000 accumulates interest, so let's look at what happens as each year passes. After 1 year, the total loan would be P times 1 plus 0,1 to the power of 1. And we can substitute P with this summation of F terms. Then if you expand this, meaning multiply each of the F terms by this 1 plus 0,1, you get, okay, cool. So the first year has passed and it's time to make your first loan payment. Let's say the first payment is F1 times 1 plus 0,1. Remember that each regular payment is X, so this would be equal to X. Since you've made this payment, it would be deducted from whatever value the original loan plus interest has become. So the remainder of the loan would be these 3 guys. Okay, awesome. I know a lot of random things are going on here, but just stick with me. Now that's the situation after 1 year. Let's see what happens after the second year. So this remainder would accumulate interest. So the amount accumulated between the first and second year is the remainder times 1 plus 0,1. Then if you multiply it out, meaning multiply 1 plus 0,1 times each of these terms in the brackets, you get F2 times 1 plus 0,1 squared plus F3 times 1 plus 0,1 squared plus F4 times 1 plus 0,1 squared. Then let's say the second loan payment is F2 times 1 plus 0,1 squared, which would be equal to X. This is the second loan payment, so it would be deducted from whatever's left of the original loan and the interest is accumulated. And the remainder would be these 2 guys, since this is no longer there. Okay, cool. Then let's see what happens after another year passes. So this remainder would accumulate interest, and the new accumulated amount would be this times 1 plus 0,1, which expands to F3 times 1 plus 0,1 cubed plus F4 times 1 plus 0,1 cubed. Then say the third loan payment is f3 times 1 plus 0,1 cubed, which will be equal to x. This would be deducted from whatever's left of the original loan plus its accumulated interest, and the remainder would just be this guy. Then the final year passes, and this remainder accumulates interest to finally give, which just expands to f4 times 1 plus 0,1 to the power 4. Then the fourth and final payment is f4 times 1 plus 0,1 to the power 4, which is also equal to x. And with that fourth payment, now the entire loan has been paid back. And from this whole exercise, we got 4 different ways of representing x. That's one way. That's another way. That's the third way. And that's a fourth way. I'll just write those equations together below this. So the question asked us to find out the value of the regular monthly payment, meaning to solve for x. And we have 4 different equations for calculating it. But the problem is we don't know the values of f1, f2, f3, or f4. So we can't just plug in their values and solve easily for x. But we do know something about them, which is that they all add up to 5,000. You can make the f terms the subject of all these equations and sub those into this equation. So when you make the f terms the subject of these 4 formulas, you get these 4 equations. Then just sub these back into this equation and you get. Another way of representing these terms is by taking the bracketed terms up to the numerator and making the exponent a negative, which looks like x times 1 plus 0,1 to the power negative 1 plus x times 1 plus 0,1 to the power negative 2 plus x times 1 plus 0,1 to the power negative 3 plus x times 1 plus 0,1 to the power negative 4 equals to 5,000. Notice that the first term is x times 1 plus 0,1 to the power negative 1, and the second term is the first term times 1 plus 0,1 to the power negative 1, and this pattern continues up to the fourth term. Therefore, these terms together would all represent the terms of a geometric sequence, and since you're adding them up, this is a geometric series. And this time the first term is x times 1 plus 0,1 to the power negative 1, and the constant ratio r would be 1 plus 0,1 to the power negative 1, which is roughly 0,909, meaning a value less than 1. And there's 4 terms in total, so n equals to 4. The formula for a geometric series with a constant ratio value less than 1 is, then you can just sub in these values into the equation and solve for x, which gives the x value as 1577,35. So to answer the question originally asked, each yearly installment would need to be 1,577 Rand and 35 cents. From this, we can derive a general formula for determining the present value of a bunch of deposits made in the future. The first term we had for the example was x times 1 plus 0,01 to the power of negative 1, and the constant ratio was 1 plus 0,01 to the power of negative 1. And the formula for a geometric series is, so by comparing to these values in the example, we can say what the general form of the first term and the constant ratio would be. The first term would just be x times 1 plus I to the power negative 1, and the constant ratio would be 1 plus I to the power negative 1. Then just sub these back into this equation, and that's how it looks. But this formula still looks quite a bit complicated. It can still be simplified a little by taking this 1 plus I to the power negative 1 term in the numerator down to the denominator, which looks like this. And if you multiply each term in this bracket by this bracketed term, you end up getting 1 plus I minus 1. where the ones would just cancel out, leaving the denominator as just I. And this is as much as we can simplify it. So we get the final equation as present value of a bunch of payments made in the future equals to regular payment times, brackets open, 1 minus 1 plus interest rate to the power of negative number of payments, close brackets, over interest rate. Let's look at an example. Caitlin takes a student loan to sponsor the first year of her postgraduate studies. The loan agreement says that the repayment period is 2.5 years and the loan is subject to an interest rate of 12% per annum compounded monthly. If she has to pay a monthly installment of 581 Rand and 22 cents, what is the total amount of the loan she took? First, just write what info the question has given you. The interest rate is 12% compounded monthly, so it would be 12 over 100 to put it in decimals, then divided by 12 to give the monthly rate, which turns out to be 0.01. They also said that the monthly installment is 581 Rand 22 cents, meaning this is the value of X. Last thing is that she repays the loan every month over 2.5 years. So number of payments is 12 times 2.5, which gives 30. The question asked, what's the total amount of the loan? So the question is asking, what's the present value of the loan? Luckily, we just derived a nice equation for calculating this and have all the values to sub in, which gives 14,999 Rand and 96 cents, which is basically 15,000. Therefore, the total amount of the loan is 15,000 Rand. The second part of the question asks, how much interest will Caitlin have paid at the end of the 2.5 years? So the total amount she pays over the 2.5 years would be equal to the actual loan plus all the interest it accumulates. Then just make interest as the subject. We already know the actual loan, and we can calculate the total paid by saying number of installments times value of each installment. Then just sub these values in, and you finally get the total interest paid as 2,436 Rand and 60 cents. Here's another example. Lisa wants to buy an apartment in Hout Bay for 5 million Rand. She already has 3.5 million Rand saved up, which she'll use as a deposit for purchasing the apartment, and plans to take a loan from Bank S to pay the remainder. The loan agreement states that the repayment period is 7 years and the interest rate is 8.6% per annum compounded monthly. First part asks how much you should need to pay back in each monthly installment. So this example is pretty much the same as the previous one with just one new aspect, and that is the fact that she pays a deposit at the very beginning of the loan. And the way you account for this is by subtracting the value of the deposit from the present value of the loan. Since the loan is 5 million Rand, the actual present value that needs to be covered is 5 million minus 3.5 million, which is 1.5 million. Then the interest rate is 8.6% over 100 divided by 12 since it's compounded monthly, which gives the I value as 43 over 6,000. If you write out the decimal form of this, you don't get an exact value and would need to round it off, which as earlier mentioned would make your final answer inaccurate. So I'll just keep it in this fraction form and substitute that wherever I appears in any equations. Then the number of payments would be 7 times 12, so 84. Then here's the present value formula, and notice this time we actually know the present value of the loan, which is 1.5 million, and we now need to determine the value of the monthly installment, so we need to make X the subject. Then just sub in the values, which gives the monthly installment as being 23,830 Rand and 23 cents. Next, the second part asks how much interest she'll have paid at the end of the 7 years. We use the same formula we did for the previous example, and the total paid would be 84 times the value of the monthly installment. And when you do the whole calculation, you end up getting the interest as 501,739 Rand and 32 cents. And that's all the new equations and stuff you need to be familiar with for the topic. The very final section of this topic looks at how to use this information to analyze different loan and investment options, so a real-life application.